Welcome. Let's take a look at a couple of examples of applying limit laws. In these two examples, we're going to suppose that the limit as x approaches 2 of f of x equals 4, and that the limit as x approaches 2 of g of x equals negative 5. Let's start by looking at this first limit. Now, the first limit law we're going to apply is the law that says the limit of a quotient, which we have here, a quotient, something that looks like a fraction, is the limit of the numerator divided by the limit of the denominator. So we're going to say that this is equal to the limit as x approaches 2 of 2 times f of x minus 3 times g of x, all divided by the limit as x approaches 2 of g of x. Now the next limit law we're going to apply is the one for a difference. We have 2 times f of x in our numerator and 3 times g of x in our denominator. So we know that the limit of a difference is the difference of the limits. In other words, I can take the limit of 2 times f of x and subtract the limit of 3 times g of x. So let's go ahead and do that. Now we're almost to the point where we can substitute these values for the limit as x approaches 2 of f of x and g of x, but we're not quite there yet. There is one more law we can apply, and this deals with the constant multiple. In other words, we have the limit of 2 times f of x and the limit of 3 times g of x. Well, the constant multiple law allows me to take those coefficients and basically pull them in front of the limit. So in the first case, we'll have 2 times the limit of f of x minus 3 times the limit of g of x. So let's go ahead and do that. So now we have in our numerator 2 times the limit as x approaches 2 of f of x minus 3 times the limit as x approaches 2 times g of x. And at this point, we are able to perform some substitutions. So wherever we see the limit as x approaches 2 of f of x, we are going to substitute in for that the number 4. And wherever we see the limit as x approaches 2 of g of x, we're going to substitute there negative 5. So that will be substituted both in the numerator and in the denominator. And so what we end up with is 2 times 4, substituting the limit for f, minus 3 times negative 5, substituting the limit for g of x, all divided by negative 5. So this ends up giving us 8 plus 15 in the numerator divided by negative 5, which is going to equal negative 23 over 5 as our limit. Now let's go ahead and take a look at the second example. In our second example, we're looking to find the limit as x approaches 2 of f of x times g of x minus f of x. So we want to apply our limit laws such that we can substitute in these known limit values. So let's go ahead, and since we have a difference here between the two parts of the function, let's go ahead and apply the difference law. So we end up with the limit as x approaches 2 of f of x times g of x minus the limit as x approaches 2 of f of x. So that right-hand limit is ready to apply, but we need to do a little bit more work on this first limit where we have the product of f of x and g of x. So we're going to go ahead and apply the product law for limits. And the product law says that if I take the limit of a product of functions, that is equal to the product of the limits of the individual functions. In this case, the limit as x approaches 2 of f of x times g of x is equal to the limit as x approaches 2 of f of x times the limit as x approaches 2 of g of x. And so that takes care of that first limit, and then we're going to subtract the limit as x approaches 2 of f of x. And these are all equal. We are now at a point where we can do some substitution. So we can go ahead and substitute the value 4 wherever we have the limit as x approaches 2 of f of x. So here in the first term and here in the second term. And then we can substitute in the value of 5 wherever there is a limit as x approaches 2 of negative 5. So we'll be able to substitute that right here. So let's go ahead and determine the value here. So this is equal to, now we're substituting in a 4 for that first factor, times, now the limit for that second factor is going to be negative 5, minus, and then substituting in for that last piece, we get 4. So we have negative 20 minus 4, which is going to give us negative 24. I hope you find this helpful.